This lesson explains how to overcome flicker in an animation window. The problem comes up when the picture is partially drawn and the screen updates itself. This causes part of the animation to briefly disappear and then reappear. This happens quickly and the image flickers. This is the smooth animation class, which is a modification of the previous example to remove flicker. The fundamental structure of the class is pretty much the same as the previous one. Here the declaration of an image reference is made. This image object is going to be used to make it possible to paint an entire frame of our animation into memory and then put the whole thing into the window in a single instruction. Notice that the body of the run loop has been somewhat simplified. It's no longer used to increment the value of x to determine the new position for the animated object. This is now done elsewhere. A new method named update has been added. You see, I lied to you earlier. Well, I didn't exactly lie, I just didn't tell the whole truth. Whenever you call repaint, Java schedules a call to update, not to paint. There is a default version of update defined in the component class, and we inherit that update method here because we're extending the canvas class, which extends the component class. Anyway, the default update method doesn't do anything but make a call to the paint method. But we do a little more than that. This update method, which overrides the default update method, is inserted to do some other things before it calls the paint method. Look, all you have to do is remember that if you include an update method, it'll be called whenever you call repaint. For now, you can forget about all that stuff that goes on backstage. The first thing we do at the top of the update method is to move x to the next position, the same as we did inside the run loop in the previous program. Next, if the image reference is still null, that means we've never come through here before, and we need to get ourselves an image object. We construct an image object that is the same size as the window we're displaying. Then we extract the graphics object from the memory resident image and use that graphics object to call the paint method. At this point in the program, the entire picture that we want to put on display, background and all, has been painted onto the image object in memory. This method right here paints the entire image onto the display. You see, the graphics object that's passed to the update method is the same one that's normally passed on to the paint method. So it's the one we need to use to paint to the screen. Calling this method to paint the entire image to the screen in one fell swoop is the whole key to getting rid of flicker. This method draws the whole picture on the screen in a single action that cannot be interrupted and cause flicker. I know this is some more of that backstage magic, but believe me, it does get rid of the flicker. Look, it repaints the entire window one pixel at a time, right? Replacing the ones that are already there. So even if it were interrupted and restarted in the middle, it doesn't matter, because at no point will any portion of the screen peek through any other portion. It can't flicker. Here, I'll show you. There. Oh, I know. It looks just like the flickering example because the techniques used for recording this movie and showing it to you automatically removes the flicker, but don't take my word for it. Compile and run both this program and the one from the previous lesson, and you'll see one flicker and the other one doesn't. It's kind of boring maybe, but it doesn't flicker. But wait, look what happens here. If you change the size of the window, the program doesn't know about it. It keeps using the dimensions and the memory resident image that it had made to fit the other window. In the next lesson, I'll show you how to resize the window and have the animation adjust to fit it. And I'll jazz up the animation a bit too.